In this video, we will continue with the pressure chamber. In the last video, we created the gasket and the cover plate. In this video, we are going to create the base chamber, and then we're going to assemble it all together. So to create this, there's three ways that jump out to me of how we could create it. So we have a cylinder with a little solid base and a few holes over here. The first way is really just four ways actually, is I could create so let's go over here and create a new metric drawing. Is you can create a circle with a diameter of 100, and I could extrude that up 20. And then I can create another sketch on top of it, and that could be two circles, one being 100, and then another one being 80, and I can extrude that as well, and that'll give me that bowl shape right here, and that will be extruded up 45. That's one possible way of doing it. Actually, I think this should have been 60, not 80, but I'm just going quick to show you a few different ways of doing it. So let's go ahead and delete that. Another way you can do it is I could have done a 100, extruded up 65, and then I could have created either a sketch or a hole to go back down. And the hole diameter would be 60, and it goes down a distance of 45. That's a second way of doing it. Totally valid way of doing it. Another way you could have done it was create this right here and then use the shell function. The shell will kind of carve into a part to give it a uniform thickness. So shell right here, you just specify the thickness of the shell, and then you just click right there. That's probably the easiest way in my opinion. The last way is the revolve command. And although the revolve command would not be an efficient way to do this in my opinion, it's good practice to do the revolve because I promise you your final is going to require using the revolve command a good amount. So let's practice using the revolve command. So we're going to create the sketch, and the revolve command essentially takes geometry and revolves it around a center line. So you're going to, let me actually do it on the XY plane. You are going to create a center line right here in the middle, and that'll go up 65, and then turn center line off, and then you're going to create like the cut section, which is going to be this little L shape right here. So it goes in 50, up 20, over 30, up 45, and then close it off. Again, the real point of this right now is just to give you practice with the revolve command. So you create a closed geometric shape, and then you can revolve it around. Okay, and that's your base pressure chamber right here. And then we're going to go ahead and create the little holes in the outside. So you should remember from the last video, you have to create a construction circle with a diameter of 75. I create a second one just to give you something to pick. I don't care how big it is, as long as it's a center line. And then when you go ahead and create your hole, you now can just pick that little center of the second circle right here. And in this case, it's not just a smooth hole, it's actually an M8 by 1.25, meaning the diameter is kind of around 8, and it goes a depth of 17, and the amount of threads is about 1.25 per, I forget exactly what it is. I should have looked it up beforehand. But this essentially is telling you like the amount of threads per centimeter or millimeter, or per unit length. I forget exactly what the per unit thing is, but this is what is being changed when you change the number. Okay, so we're gonna go over to nice tapped hole. What did I say? 8 by 1.25, is that what I said? Okay, and we're gonna have the distance be, it's gonna go down 17. And a few other things to note is that you can adjust these dimensions right here, and look at what it's telling you. The overall distance to the termination, and then the distance of the thread. So let's look at what we have over here. And looking at the cross section, it seems like you have the threads going the entire way down up until it tapers off. So you do want to taper off. So the taper off is shown right here. Notice how this changes. So we do want the taper off one, and we want the total distance to be the same as the threaded distance. So we're going to do 17 for both and hit OK. Yeah, I don't know why it looks funky. I guess it's my computer just handling the graphics poorly. Okay, now we'll do a circular pattern. So I'm going to do circular pattern, choose the feature, the rotation axis, either circle, and I want 8 total. Okay, and then we have to do the hole in the middle, which is an M24 by 3, which is the same as the top one over here. So hole, concentric, select, M24 by 3, and we want this to be through all. Okay. The material of this is steel, so just make it steel. And change the color if you would so choose. It's good just to have everything be different colors. It looks better on your presentation. Gorgeous. I don't know, I like that home view, so I'll make that my home view. I don't even know if that matters. Okay, and we're gonna do File, Save As, and this is the, let's get the wording exact, base chamber. Okay, so now that we've finished our 3 parts, we are now ready for the assembly. So I'm going to go to New and Assembly and do a standard millimeter Inventor assembly. The first thing you're going to do once you're in your assembly file is bring in your parts. So I'm going to go to Place, and because I'm bringing in a part file, I'm going to go Place. Find where you saved it. For me, it's in a folder called Pressure Chamber, and I have one instance of the 3 of them, so I'm going to highlight them all at once and hit Open. Okay, I don't like that home view, so I'm going to immediately change the home view to something that looks good. I'm always so bad at choosing like the right cube face. Something like that, so then this one. Okay. And once you have this, the first thing you have to do before you add your constraints is you have to ground one of them. To me, I think it's obvious to make this one the one that can't move, and everything moves about it. So I'm going to right-click this guy and tell him you're grounded. And now when you right-click, grounded is checked, and I can't move it. I can move the other ones, can't move that one. So you can constrain these holes to these holes without actually having a bolt there. This is kind of where Inventor doesn't take physics into account. So I'll just show you. Constrain. Remember, insert constraint. Cannot forget that. Not mate. Insert. And essentially, you want this one to go to, well, anyone, right? Because they're going to have the same center. And why is it yelling at me? All right, maybe I must have done it wrong. All right, sorry, let's try that again. Insert the bottom to right here. Okay, I don't know why it didn't let me do it before. I'll guess I can go back in the video and see what I did wrong. Okay, so now it looks good, right? But it's actually not, because only one of the circles are now like constrained. So I could rotate it this way. That's obviously not what I want. So how do I get around that? You just have to constrain another hole. Now I can't do this hole and this hole because those two holes aren't supposed to be on top of each other. I can do this one and this one, this hole and this hole, this hole and this hole, and you get the idea. So I'm gonna move it just so I can make sure I'm aligning it up properly, and then I'll do constrain, and I'll make sure I do mate, or sorry, insert, do not do mate. Ugh. Okay, and then do the bottom of this one to the top of that one. Boom. And now it can't move. We'll do the same thing for the top. And we'll say the bottom of this one to any one, doesn't really matter. Okay, and then you might say, oh, it looks good, but it really can move around, and I don't like that it can move around, so you gotta do it again. Line it up so you can kind of get a good view, and then do the same. So the bottom of the red one to the top of the other one. Okay. Oh, I thought I changed the home view. Okay, so now we have to add bolts. You do not have to actually create the bolts. You will be importing the bolts from the Inventor library. So to place something from the Inventor library, you can go up to here, and instead of place, you're going to actually go place from Content Center. Content Center is the library of Inventor where you can find everything. And here are all the predefined objects. So bolts would be under fasteners. So I'm going to expand fasteners, expand bolts. And to be honest, guys, I don't care exactly which specific one you do, as long as it's one that says 8 by 1.25. So let's see if we can find one. It's I kind of forget exactly where that one might be, but I care more about you having the ability to pull in a bolt than getting the exact one they show. Don't tell Lisa. All right. So let's do hex head, self-tapping. There's like 100 of them. I don't know exactly. Definitely get one that says metric. Okay, so this one. Or metric. See, I don't know what type F means. All right, let's just do one that, we'll start with this one. So click to start placing it, and then a little dialog box will come up. For thread description, hit M8, make sure it's 8, and then the nominal length should be 30 long. So choose 30. And let's do as custom. What that means is that you don't want to save this because that'll change the description in the library and you don't want to mess with the library book. Do as custom to keep it specific to this project. And we're going to need 8 of them. 2, 3, 4, 5, 6, 7, 8. Okay. And then constrain, insert. So just kind of move it so you can get a nice little, the bottom or the top, the bottom of the head to the top of this. And hit apply and then do that 8 times. Okay, and we are done with the assembly file. So we're going to go to File, Save As, and this is called the pressure chamber. Okay, that's it for this video.